Hi, this is Doug Sargent. Welcome to the Karst Valley Railroad. All aboard!
Okay, today I'm experimenting with Kato number 4 turnouts, derailing, and track geometry. Here we go.
There's been a lot of talk about the Kato number 4 turnout regarding almost constant derailing. It is very frustrating and makes me feel a bit like I've been suckered. I'm sure that those of you with number 4 turnouts know what I mean. I want to keep using number 4s due to the space constraints that I have, and of course the fact that I already laid out quite a bit of cash for them. For this test I'm using a Bachmann EDM SD9 as the motive power, and it consists of 3 microtrains, 9 10-10 hoppers. As you see here, they have different couplers. There is also a slight height difference, but I found that the couplers are not part of the problem. I have simplified the original plan here. Notice that there is a 315 millimeter radius curve leading directly into the points. So as the train comes around that curve, because the coupler on the locomotive is fixed, you'll see it swing out and pull the coupler on the hopper way over, which actually causes it to reach its limit and turn the truck up, and that's why it's derailing. Now, this happens on either the straight or the curve. This time the locomotive derailed. I've added a 64 millimeter straight just before the turnout. This helps to straighten out the locomotive so that coupler is more in line within the limits of the hopper's coupler. Now, I've noticed that this increases the chances of it getting through that point. You'll see a 124 millimeter straight in the back there, which I use later. Now, coming into the curve, again, we saw the locomotive derail before. This swings right through there nicely. And I'm not hearing any clicks most of the time. The click indicates there's a little bit of a hang up on the points. So I sweep right in there. That's with the 124 millimeter straight in front of the point. And you see that? The whole locomotive's nice and straight when it goes into the turnout. So my conclusion is that track geometry has a lot to do with why my turnouts are derailing. I found that the 64 millimeter straight in front increased the probability of success quite a bit, but I still noticed some clicking, which indicates that the couplers were reaching the limit, and I found that the 124 millimeter increased the performance above and beyond that. I found it safer. Now, of course, this means that you're not really saving any space by using a number 4 with a 124 millimeter. You might as well just use the number 6. But this is the way it is. That's about it. I'm Doug Sargent with the Karst Valley Railroad. Thank you for watching. Don't forget to like and subscribe. Over and out.